it should copy not something. And then in this parenthesis, it says more things that are not to be copied. So it only says in this line what stuff is not to be copied. Now that's very weird.
Hey guys, welcome to Embedded Toolbox, the video interview series where we try to save the world by solving one engineering challenge at a time. And an engineering challenge that most developers the world over face is trying to get C to requirements, getting that traceability. And to help us out with that, we brought on Marcel Beemster, who is the CTO of Solid Sands. How are you, Marcel?
I'm fine, great. Thanks for inviting me. It's really exciting to be able to talk about this in a bit more technical detail than I normally do.
Obviously, the C language is widely used and widely deployed. So when you're trying to implement requirements based on some maybe ambiguous at times standards, what are some of the challenges you see some of your customers and developers everywhere facing?
They want to have a requirement-based test suite for the library that they use. And that really means that you have to cover this whole path from the specification to the library. Now, let me show you what I mean by that. So what I've got here is sort of the V model. And you can imagine this is the V model for the C library implementation. So the V model starts at the left side with the high-level goals of the library. At the bottom, we find the implementation of the C library. And between that, there are the requirements of the C library. Now, we have, of course, the ISO C standard specification, and that's a very good document. It's an ISO document, so a lot of people have seen it. Everybody is using that. Everybody agrees on that. That's a real standard. But it's not a list of requirements. Now, what do we need to do? We need to show, in the end, how our tests that we have here, how they correspond to the ISO C standard, and to make clear that every requirement in the ISO C standard is really there. And then out of that comes requirements and test report that says, okay, for this line in the standard, you have the test over there, or you have the requirement over there, then you have the test, and then the result of that test. So that is what's called traceability. And that is what you need to show if you want to deploy a test suite in a safety critical environment. You really have to cover this whole thing. Now, we had a very good test suite. We had the link between the test suite and the C standard, but we didn't have these library requirements very clearly spelled out. And now you can think, of course, okay, library requirements, they are in the standard, right? So that's not so difficult, but that's not really true. You really need to dive into that. So this is a strn copy function, although it's a bit of a hairy text because you see here to explain this first sentence, they actually needed a footnote. So that's weird. You should not need a footnote there because the specifications should be clear. Now, if we zoom into this a little bit, so I make it readable to you and to the audience, then we see that this text, I've split it up in these 4 parts. And the bottom part, that is a clear requirement. So that part of the specification, we can turn there's a one-to-one correspondence between a requirement and the text here. And the requirement is the string copy function shall return the value of S1. And S1 is the first argument. So that's a very clear requirement. The second, from the bottom, second green part says, well, if the stuff that you've copied, so string copy function should copy a string, but not more than n characters of the string. Now, if the string is shorter than that n, then the function should fill the rest of the target array that it has with null characters. So that's what it says. Null characters are appended to the S1 array. So that's also a very clear requirement. If you haven't filled up the target array, fill up the rest with null characters. So that is very clear too. But then we get to this part here. And this is something I don't like about the organization of the C standard, because suddenly here you do not find a requirement, but just a description of undefined behavior. And actually what the C standard should have for functions like this is a list of preconditions. So this is actually a failure of taking the preconditions into account by the programmer. So this is not a requirement on the implementation. This is a requirement on the program. The programmer should take care that S1 and S2 are not overlapping. So that's a precondition for the function. And if you organize it and show it like that, that's a much more clear organization of the requirements and the preconditions.
So why would C write the requirements this way? I mean, it's almost like, it almost looks like it's intentionally ambiguous.
Yeah, well, it's certainly not intentionally ambiguous. And fortunately, it is not ambiguous because millions of people understand this text and they know what string copy is supposed to do. But I think, and I'm pretty sure of that, and I'm going to show you that in a moment, I think that this text was written by the implementer of this function. So the implementer of the function was thinking about, okay, I'm doing this in the implementation, then I'm doing that, then I'm doing that. And the implementer found out, okay, if these objects overlap in my implementation, yeah, then something goes wrong. And that is how it is written. So the implementer wrote it like this, figured out, okay, something goes wrong. And yeah, that's undefined behavior. And yeah, today we're very used to the notion of preconditions for functions and really writing them down nicely, etc. This is 1989, and yeah, okay, the notion existed, but it wasn't as widespread yet. As it was really popularized, maybe by Eiffel, one of the early object-oriented languages.
Got it. Okay.
Okay. Then the first sentence, that is the really problematic one, because yeah, you expect the first sentence to say, well, it should copy something, right? It should copy this S2 string, but it doesn't say that. It says it should copy not something, and then in this parenthesis it says more things that are not to be copied. So it only says in this line what stuff is not to be copied. Now that's very weird. And as I said, fortunately everybody understands what this is supposed to do, but this is not the proper requirement for the function. And yeah, let me show you how I think this corresponds to the actual implementation of this function. So I'm going to switch again to my editor. This is the editor where I can show you some tests around MB2WC. By the way, this is Compiler Explorer that we sponsor. We're quite proud of that because it's a very useful program used by many people. I've created this example over here where I test the string copy function for 5 cases. And currently it's set so that it's testing the library function. So really the function that is in the standard library. And these 5 cases, first of all, copying an empty string into a target array of 5. That's passing, that's fine. Copying an empty string into a target array of 0. Now I think the library implementation is actually fine. So I have no problem now with library implementation. But let's think about what the implementation could look like. So here I've implemented my own string copy function, and I'm now going to replace the library function with my own implementation of string copy. And this is the one that actually interprets the line literally. It says copies no more than n characters and do not copy anything here. So it doesn't say copy anything. So this implementation doesn't copy anything. It only fills out the rest of the array with zeros. Now that's not correct. And if we run the test now, then we see, okay, the final 3 cases have now failed. So this is a clear indication that this is not working. Right. But now what did the programmer think? Well, the programmer thought, okay, how do I implement this? And well, how do you do string copying with a while loop? So he wrote while. And the first test is, okay, when should I terminate the while? If there are no more than n characters, okay, I should have at least 1 character. So I'm typing 1, 0 should be larger than, n should be larger than 0. So that is my first condition. Next, I have to copy from froms to to's. So I'm going to do that if this is okay. And at the same time, I can test that my final character is 0. So that's a very common trick in C. I don't recommend to use that, but This is how you would write it in the old days. You would write the target string here, plus plus equals star from string plus plus. So you're reading a character, copying it into the target, moving the pointers forward, and at the same time, you're testing the result, the character that you have copied. And as soon as you hit the final character, then you hit the final 0 character and you stop, because then this condition becomes 0, and that's the end of it. Now, there's one more thing I should take care of, and that is making sure that every time something is copied, the n value is reduced. I can't do that here because this is always executed, and oops, I only want to execute the counting of n if this is actually true. So I'm going to put it over here. So I'm putting an n min over here, and I'm putting an end over here. So now I have a very complicated condition, but this condition almost reflects what it says over here. Copies not more than n characters. Here we go. N has to be larger than 0. And I'm copying something from the to string over here, and I'm checking the null character at the same time, because I'm putting this copy operation in the while condition itself. And then the only thing I need to do to make this correct, hopefully, let's see if that runs, is add the terminating semicolon. Godbot will hopefully take care of that. No, because I wrote from instead of froms. Let's fix it like that. And now we have a correct implementation of the function. We have 5 passes again. So yeah, this is why I think the line that's there in the standard is just the English version of the line that we have here in our program. Okay, so yeah, this is a bit playing with word, but it is symptomatic of what we see in the language standard. You really have to think hard to take this text from the standard and move it into requirements. And that's why we have worked very hard to make all the requirements really clear out of the text that is in the C standard. And then based on that, we can say, okay, we have now all the requirements. We can describe that in our test with test specifications and our requirement-based test. And then we can create a report that connects all the dots. So that's the traceability. And the traceability, that's what's so important in functional safety. You have to show how things are connected, how you get from one to the next one, to the next one, and make sure that it is all verifiable, that you have a really nice written report and you can check that all of these bits are correctly handled.
And
I'm not going to go into depth. Sorry, what did you say?
And that's SuperGuard, right?
That is SuperGuard, yeah. Yeah, we also, in addition, we have taken care of code coverage, that we have with our test good coverage of the C library, which is an additional requirement in many industries. But it's this traceability, that's what we can get out of that is, well, actually we get the spreadsheet because there are many requirements and every line in the spreadsheet is this horizontal traceability for every bit and piece. But what's in one of those lines is, first of all, we identify, okay, in the C standard, in that section, we are validating the string copy function, that's the name of the section. And we are talking about this unique number of the requirements. So this is about the copy string requirement that's referring exactly over there in the C90 standard. And then we have written here our requirement. And this is a much more readable requirement. This is half of the first sentence. It says, if S2 points to a string with a length of L2 that is less than n, then string copy shall copy so many characters.
Right.
So this is the case where the length of the string is less than n. There's another requirement where the length of the string is larger or equal to n. And then it also says it shall copy so many characters into the target array. So this is a clear requirement, not the thing that was in the standard.
Yeah.
And the next part is that we have here the the test. So this is the unique identification. This is the path to the test. And we have here the test specification that explains, okay, how are we going to test this requirement? And we identify here also, also special cases like a string with a length of 0, for example. So you make sure that your test takes care of the different cases as well. And finally, there's a result. This is passed. Now, this is a textual output. Not so nicely organized here, of course, but in the spreadsheet, the spreadsheet is just a very long line of outputs like this, and everything in there is verifiable from the source to the final result. And that is what SuperTest is, SuperGuard is, and that is our product basically.
Great. And I mean, all those standards there are supported by SuperGuard listed here.
Not yet. We're working very hard on all of this. So on the left side, we see that one day actually there was a book in the C about the C standard. That was the C99 standard that was published as a book. It was very nice. With SuperGuard, we soon have an update, and then we cover this top row of batches from C90 to C18. And we're now very hard at work with the C++ standard as well. So the C++ standard, it's used so far until maybe 2 years ago. It wasn't used that much in safety critical applications because the technology didn't need it really. But nowadays we see, so much more complex programs in safety critical applications, and you can think there about self-driving cars, for example, that they want to use C++ libraries, software written in a bit higher level language than C. And so we are very hard at work to creating also SuperGuard for C++. So we'll let the world know when we're ready with that.
Well, that's some great stuff, Marcel. Obviously, I mean, it's saving developers of safety critical applications a ton of time, not to mention a ton of brain power trying to figure out those requirements, that traceability requirements. Where can interested parties go if they'd like to play around with SuperGuard and see how it works for themselves?
It's very easy. Solid Sands.nl. There you can find everything about us, obviously. And over here, you can request the demo. Now, the demo is not specific for SuperGuard, but with the demo, you can see there's a lot of documentation in there about our own test platform. If you have any doubts whether you can implement our test platform with your environment, and we do implement also target, we can run the test on target devices. We can integrate very easy with continuous integration environments. If you want to try out and see how that works, then do get the demo. Documentation is in there. You can play with it. And then, of course, if you like it, you can find the rest of the information here on this website as well.
Well, thank you so much for your time. And we look forward to that next time when we're back on.
Thank you, Brandon.